Principles and elements of design. In the course description, I think that's what it says. It's a class about the principles and the elements of design. So what's the difference? What is a principle? What is an element? And how does that have anything to do with what we're talking about here? A principle is an abstract concept that organizes some elements in a composition. What are the elements? The elements are the perceivable phenomena, the actual contents that you experience. So the elements of a painting might be shapes and lines and colors. The elements of a song are the notes and the rhythms that you actually hear, the sound of the drum hit. The contents of your experience are the elements of whatever the thing is you're organizing, right? Whether it's a building or a wedding dress or a piece of classical music or a painting or a video for YouTube, whatever it is, it's made of parts, right? It's a composition, a composite. A composition is something composited together, something made of multiple pieces that cohere together to make one thing. All those different elements that you need to cohere to make your project, whatever it might be, to make your composition, they're going to cohere if they're organized according to some principles. So design is a process of applying ideas, principles, notions about organization to things and experience, elements. How do we organize the contents of our experience such that multiple elements can come together and become one cohesive thing? Whether it's a painting or anything else, right? So many things you could think of in this sort of broad context of a composition. A design class like this, I think, will help you in any field you are studying. It will help you to write a better lab report. It will help you to write a better essay in your English class. It will help you to organize any complex thing that you are producing. So, an example of elements and principles. I can look right here at my own hands, right? These two hands in front of me. I have some experience of these hands. How are these hands organized? What's the principle? Symmetry. I'm more or less symmetrical, less every day, right? Less every year. But human beings and animals in general, not all animals, are organized according to axes of symmetry, at least on the external perception, right? Internally, your organs are set up somewhat asymmetrically, right? But your ear seems to be kind of okay where it is because there's one like it on the other side. Normally, in a class full of students, on day one, I have everybody turn to the right and look at the person's ear sitting next to them. And we sit like that for some uncomfortable period of time until everyone's kind of done giggling. And I say, God, that ear looks bizarre, doesn't it? Right? Like if you look at the actual shape of a human ear, it seems quite disorderly. It's hard to identify the principle. But when the person turns their head and there's one just like it, just as weird on the other side, it seems okay, right? The composition of the head coheres around the organizing principle of bilateral symmetry. The element of the ear in isolation, which would seem so random and malformed, seems totally justified in its duplication as a mirror image of itself on the other side of the axis of symmetry. The principle of symmetry has been applied to the elements of the body in such a way that the body coheres as a non-random set of elements. This is one of the primary things to learn in this Design 1 class. How can you apply principles of organization, organizing principles, to the various elements of a composition such that those compositional elements unify? Okay, so the first part of this class, we're thinking about color and color theory. I just recorded a video, I'm not sure whether it will show before or after this one, probably after, about color and the phenomenon of color and where color exists. In this video, I try to make the claim that color is all in your mind, right? That there is no color out there in the universe, that color is part of your mental space. Color exists in the mental space. Where is the color red? It's not on any red object. It's not out there in space, not in physical space. It exists fully inside of human mental space. We have all of these different colors, which are such an important part of our visual vocabulary. Our visual culture uses color as one of the primary variables of communication. In visual design, color is very fundamental, and it's an element that we perceive. Right? It seems like we're perceiving it out there in the world, though I like the argument better that we're actually producing it internally from our perception or our exposure to some stimulus, which is not itself the color. It's an element, right? Even if it's a psychological element within us, it's part of those things we are receiving as information from any composition we look at. What color theory aims to do is apply principles of organization to the element of color in a given composition. So there are color systems. And there's not just one color system, right? There are systems. You might have at some point learned about the color wheel. It's very common for students to come into this class having learned something about color theory in a previous class or in high school or junior high school, all the way down to your elementary school education. You probably learned something about a color wheel and some primary colors. What usually wasn't told to students is that the color wheel is a cultural convention and has changed over time. And there are many color wheels, and they are contingent upon historical and cultural factors. They are not facts of nature. The most common color wheel that students come to this class having experienced is one in which the colors red, yellow, and blue are posited as primary colors. And the secondary colors would be orange, green, and purple. So complementary colors, typically at this point, if I ask a student, what's the complement of red? They will say green, because you've learned this thing called the color wheel. We're going to back up a little bit right now and look at a little bit of the history of the color wheel. You have a reading to do on this. I've already put that up in Canvas, but I'll just contextualize that a little bit with a video summary. So this, I think for our sake, we'll begin this conversation 1704. So we'll go back to 1704, and Isaac Newton has just published his book, Optics. Isaac Newton is doing a set of experiments using prisms and lenses to refract light, trying to understand what light is. Now, to understand something about Isaac Newton's work, you have to also understand something of the time in which Isaac Newton is working. There's not even really a thing called science yet, right? Isaac Newton is kind of on this edge of natural philosophy that is going to become science. And the whole European world that Newton is living in and existing in intellectually is just at the cusp of this thing called the Enlightenment, which Newton's helping to bring on in some sense, and has been steeped for over 1,000 years, almost 2,000 years already at that point, since the fall of Rome. Okay, so it's I can't add while I make this video. In total religious dogmatism, right? That has been the organizing structure of all thought in Europe. Newton's starting to do these experiments and say, rather than just listen to what the person from the pulpit has to say about this or read about this in the Bible, I'm going to actually test some things out and try to figure out big questions. What is light? That's a good question. Now, light has been a metaphor for purity, like the pure white light of God. So Newton is dancing on some dangerous territory here by saying, let's try to understand a little bit about what light is. And he does this experiment breaking light through a prism and sees that if you refract white light through a prism, you get all the colors of the rainbow. So he makes the idea here that white light, is not a singular entity, but is in fact a composite of all of these different colors mixing together. And he's able to develop a theory of light and color that understands something about additive color mixture. Now, in the video that I made a moment ago that you'll see here about where is color, we talk about the electromagnetic spectrum. Now, Newton didn't have the concept of the electromagnetic spectrum yet, to my understanding, but he did begin to understand that when all of the different colors of light come together, they produce white light. So Newton makes the first color wheel that I'm aware of, and there's an image of it in the slides. You'll see that in your readings this week. Newton's color wheel takes this band of color that we experience as the rainbow, right? That goes from red to orange to yellow and all the way up through to violet. which is a linear band. And he takes the two ends of that band and wraps it up into a circle so that the red purple on one end touches the red at the beginning, and it seems to go quite smoothly. Right? Why a circle? That's the first big cultural move that we have here in color theory. The taking of this linear progression of light from longer wavelength to shorter wavelength. Though I don't think Newton was thinking of it in those terms. It's a linear band. It's a little slice of the nature of the universe, right? There's all this energy out there, and we can see this little section of it. And to take that section and wrap it up into a circle and join the two ends was a big ideological leap. We can speculate as to why maybe he did that. Well, one color kind of appears to be similar to the other, right? The red, purple, and the red seem like they could flow into each other. The circle also has some semiotic significance. I'm sure it did to Newton. Newton was a real kind of cosmic thinker, right? He was, besides being involved in the Catholic Church that ran that civilization, he was also involved in alchemy and astrology and all kinds of semi-occultist practices. And he was searching for mystical answers, right? Why was he doing all these experiments? Newton's trying to understand the divine mind. He's trying to study the world so he can better understand what he perceives to be a god or a divinity. And the circle was a powerful metaphor in Christianity. What's the definition of a circle? All points equidistant from a center. Imagine taking a compass. You put the needle in one side, and then you find all the points that are equidistant from that needle. A circle is just every point which is equidistant from some center. The central point, the one thing in which all things are related to the one. Sounds like a very apt metaphor for a monotheistic theocracy, right? Okay, so the circle was also this infinite symbol. So it's infinite. It has to do with monotheism. It's got this perfect order to it. There are no irregularities, no edges, no corners. It's an apt metaphor for someone thinking in Newton's time. Let's take this piece of nature and wrap it into this perfect structure. The next big ideological move that happens is to take this continuity of the electromagnetic spectrum and make it incremental, to break it into pieces. How many colors are there? It's an open question, I think. How many colors are there in Newton's color wheel? Well, he takes the wheel, once it's been wrapped around into a circle, and divides it into 7 named colors. But I would ask you, how many colors are there between red and orange? How many can you see is maybe a better question. We could, and we will in this class, start with one hue and incrementally paint in sub-perceptually small steps from one hue to another. And we'll see that there is some threshold of your perception, at which point 2 colors, which you know must be slightly different because you change the paint a little bit, you really can't see the difference. So maybe there's a perceptual limit to how many colors there are, but that's really a limit of our eye. The spectrum is an analog system, right? And there are, barring quantum limitations, maybe there are potentially infinite divisions within that system. It's infinitely dense, but not in Newton's wheel. He's only got 7 colors in there, right? So the extracting from nature some section, the geometrization of that section into a circle, and then the incrementalization of that geometricized section of nature. Now we have layers and layers and layers of cultural conditioning being laid onto this phenomenon of color. That's what culture does, right? It takes things from nature, from experience, and works on them and manipulates them and recasts them. And in doing so, traditions accumulate. The wheel that you've inherited, your red, yellow, blue color wheel that you learned in elementary school, we're going to see here the genealogy of that wheel, essentially. Okay, so back to Newton. Newton gets these 7 colors. Newton tries to analogize what he's doing with color to what others had done with sound when designing the musical scale. If you've ever played a piano before, you would recognize this 7-fold division. There's the color wheel slightly after Newton, that I put together, had the 7 wheel colors of Newton, and then the subsequent 12 division, right, for the secondary hues, a 7-wheel and a 12-wheel. This is very much like the piano, right? If you take the spectrum of possible frequencies the human ear can hear in one octave, there could be many, many notes between, B flat and B. But on the piano, there is no option there. There's only B flat or B, and you can't go in between because it's been incrementalized. The designing of that piano keyboard took people a very long time and is also culturally continued. You don't find the same division of sounds cross-culturally around the world from all civilizations. That's a Western European tradition. And Newton, working in that tradition, adopted that work that had been done on the piano keyboard and tried to apply it to color, wrapping it into a wheel to create essentially an octave of color. It's not really an octave, it's kind of an awkward fit, right? These idealisms are always kind of a force fit, trying to take this complex, irregular nature and squish it into a box that we can understand quite well. Oh, a perfect circle, divided by 7, just like the piano. Okay, so later on, let's move forward. You have in your readings another color wheel by Goethe, German romantic thinker. Goethe's wheel's a little different, right? So in 1810, Goethe publishes a book on the psychology of color and emotion. And here we find Goethe's color wheel, and this one only has 6 colors. Well, what happened to the 7th color? I thought this was about the musical scale, right? Goethe's approaching it differently. I speculate on Goethe's motivations here, but I think that the symmetry of the 6-pointed wheel would appeal to Goethe's idealistic German romanticism here. He also had a connection between which colors are invoking which emotions, right? That certain colors were triumphant and others were despairing and others were cowardly and others were bold. And all of this kind of emotional content is kind of a human-centered experience of color. Goethe's color wheel gives you the red, blue, and green, red, blue, and yellow primaries that you have inherited, but you haven't gotten them directly from Goethe. You have this 19th century German romantic wheel that's all about the emotions of human experience in relationship to nature. We'll come back to that in just a minute. The wheel we're primarily going to use in this class comes about in the early part of the 20th century from Professor Munsell. And Munsell's wheel tries to make a color system that has some empirical experimental basis upon which it is built. So one thing that Munsell does is take a look at the color wheel and say, okay, it's wrapped up in a circle. There should be some concrete reason why one color is opposite to another. There should be a way we can tune this color wheel so that it makes sense experimentally. And the way he does this is by asserting the sort of initial axiom of his system is that complementary colors neutralize one another completely. What are complementary colors? Complementary colors are 2 colors which are directly across from each other on the color wheel, 180 degrees across. If you start anywhere on the color wheel and draw a line through the center of the wheel and out the other side, you're going to pass 2 complementary colors. The center of that wheel is neutral. It has no color whatsoever. And the 2 complements, when you mix them, produce that neutral. So Munsell set up these painted cards that would spin with an electric motor so he could get the optical blending of 2 colors. And he kept adjusting them until he had a system by which he had a color wheel, and every point on that color wheel, when mixed with its opposite point all the way across the wheel, completely neutralized, essentially a well-tuned color wheel. And then he renamed all the colors. He named them all with these numerical names because he's living at the time of the beginning of global capital, right? And if you are manufacturing something remotely, it doesn't do you any good to call up your manufacturer halfway around the world on the telegraph at that point and say, oh, I'd like you to produce me, 1 million units of this thing in rose red. Because if that person walks out their door and looks at their roses and takes the red and matches it and then makes that and sends it to you, you look out your door and you find a slightly different species of rose and say, this color isn't right at all. This is not what roses look like. He says, this will not do. This kind of nomenclature of color, which is so subjective, we need a numerical and empirical way to discuss color. And we need to name colors using tools that are reproducible cross-culturally. numbers. So he gives us a 3 variable system for naming colors. This will be an important thing to know in this class, that there are 3 primary variables of any given color. When we say a color, what we mean is a specific combination of these 3 values. And they are, as Munsell calls them, hue, chroma, and value. Hue, chroma, and value. We're going to see that they have some more contemporary names as well, which we will use more often, namely hue, saturation, and brightness. Saturation being analogous to chroma, and brightness being analogous to value. But Munsell calls them hue, chroma, and value. What is a hue? A hue is a given wavelength of light. So imagine your colors of the rainbow all wrapped up around that circle that we still had from Newton, right? Newton's round color wheel is still with us. Ideas, once instantiated into a cultural system, can persist for quite a long time. I mean, we still talk about watching the sunset, right? Buckminster Fuller was always on about this idea of like, people are still talking about going to watch the sunset. We've been knowing that the sun doesn't set since Copernicus, yet we still like to go watch the sunset. Things linger, don't they? Okay, so the color wheel is kind of like that. Anyway, Munsell's wheel still has that circular shape, and colors that are across from each other are neutralizing because he's been doing these scientific experiments using ways of blending them so that they're tuned perfectly. And he has these 3 variables of color, hue, chroma, and value. The hue is the space that goes around and around the wheel. So the difference between red and orange is a difference of hue. The difference between orange and yellow is a difference in hue. To move around the wheel from red down toward blue-green is to move in the space of hue. Now, chroma is the intensity of that hue, or the saturation of that hue. You can have a blue, which is bright, intense, full chroma blue, electric blue. Or you can have a kind of muddy blue-gray. Or you can have a gray, which is just barely bluish. Though they're all the same hue of blue, the intensity of that blue is called the chroma, the level of chroma. The lowest chroma is in the middle of the color wheel, at the neutral point. To be neutral is to have no chroma. So in Munsell's system, we have 5 primary colors: red, yellow, green, blue, purple. And we have secondary colors in between those, right? And they're named for the primaries because Munsell's scientific. So strange, but in Munsell's system, the color that comes between red and yellow, what you and I would probably call orange, he calls red-yellow. Because it's not a primary thing, it's a secondary phenomenon that comes from a mixture, so it's made from that mixture. The color between blue and green, blue-green. Now, if you look at this on a chart, as you have in your notes on Canvas here I've already given you, you'll see the opposite color of red, the complement, is blue-green in Munsell. I find that if you actually mix red and green, you don't get perfect neutral. It's a little muddy. If you mix red and blue-green, you get dead gray, right? Zero chroma. Those are the complements according to his experiments. He did this by way of experimentation, not by emotional response, the way Goethe made it. Now, you can still go places where are going to teach you Goethe's wheel, right? So the chroma of the red would be decreased by adding its complement of the blue-green. More and more and more so until you have an even perceptual mixture resulting in a neutral color. So chroma, the space of chroma, goes in toward the center and out toward the edge of the wheel, while the space of hue goes around and around the wheel itself. But I said there were 3 variables, right? Hue, chroma, and value, or otherwise known as hue, saturation, and brightness. What about brightness / value? Our wheel has a center and an edge and around and around. What we really need is a 3-dimensional color model. This flat color wheel won't do. It's not enough information to express the 3 dimensions. We need a 3-dimensional model. How about a color sphere? So Munsell makes a color sphere in which around and around the sphere is the space of hue. In toward the sphere center and out toward the sphere center on its lateral axis is the space of chroma. And the vertical axis is the space of lightness or value. Right? brightness? How relatively light or dark is the color? Sometimes students confuse chroma and value. One is about intensity and saturation of the hue. The other is about its relative lightness or darkness. So if you start adding white to a color and making it lighter and lighter, two things will happen. The value or brightness will go up, but also the chroma will go down some, right? Anything you add to a pure hue is going to decrease the chroma. We'll learn more about that when we start mixing our paints. For right now, I want you to understand there are three dimensions of color: hue, chroma, and value, also more contemporarily called hue, saturation, and brightness. Okay, now back to where you got your red, yellow, blue color wheel from. After Munsell has made his wheel, really starting around the same time, a few years after, at a school in Germany called the Bauhaus. Bauhaus is a school of art and architecture and design that starts up in Weimar, Germany between the two world wars, right after World War I, and it's disbanded before the outbreak of World War II because of the political pressures and atrocities of the Nazis drove all the intellectuals and Jews out of Germany, or not all of them, unfortunately, but many. The Bauhaus was disbanded and scattered. Many came to the United States at the rise of the Nazi Party. But in the interwar period of Germany, the school called the Bauhaus rises up. And this is really the birthplace of much of what we understand as the aesthetics of modernism. So the wheel that you have probably seen that was just called the color wheel is really a color wheel that was worked up by Johannes Itten, who taught the color theory class at the Bauhaus. And Itten was a kind of mystical German artist who, I'm not surprised to see, adopted the structure of his color system from this iconic German philosopher, scientist, artist, poet, romantic Goethe, right? So now we have the return of Goethe's color wheel into the modern era through the Bauhaus, through Johannes Itten. That is the wheel which has become so popularized that it's in every elementary school, yet it goes nameless. Watch out for cultural constructions which don't bear the name of an author. They may be masquerading as natural fact. The Johannes Itten color wheel is useful, but it's not tuned according to this kind of technique of complementary neutralization, and the colors are not numerically describable in quite the same way. It's often used by fine art painters. It's not so well used with software or with industrial manufacture or fashion design or any kind of field that involves exact replication of colors. Okay, so all of this is just to kind of recap what's already in the articles and readings and slides that I've sent you. The takeaway here is that there are principles and elements of design. Principles are ideas that organize the elements, which are perceptions, into cohesive compositions. Color theory is a way of organizing our experience of the natural fact of color into an incremental system and giving cohesion to various colors within that system. As we'll see in a future video, color wheels are used to generate color harmonies, which are color groupings, usually designed by inscribing regular geometric figures into that color wheel. Further idealism on top of our nature. The actual world out there, the nature we experience, is quite irregular. And we impose regularities in a kind of idealistic move, but nonetheless, it's what our culture is in some sense based on, the imposition of regularity and structure onto irregularities that we discover in our environment in the attempt to gain enough handle on those pieces of the environment that we can synthesize with them, that we can build. In this class, you're going to learn to synthesize color. At the end of your study of color, you will be able to look at any color you find and use pigments to match it quite exactly. In addition to thinking about color in here, we're going to think about the spatial organization of two-dimensional projects for the most part. The study of design is the study of how to organize the parts of a composition. We're going to start with some simple two-dimensional compositions. We're going to talk about organizing principles. We're going to talk about repetition and pattern and symmetry and tiling systems and rhythmic structures. We're going to talk about color and color theory. We're going to do all of this learning about organization through hands-on projects. So get the tools that are on the list to the best of your ability, and meet me up in office hours to ask questions about the assignments as they're posted. Looking forward to a great term with you all.